Good morning, students. So we are going to see exercise 3.2, the problem number 6. So the problems are involving arc length and the center angle and the radius. Okay, look at the sixth problem. What is the length of the arc intercepted by a center angle of measure 41 degree in a circle of radius 10 feet? Okay, you see that? The center angle measure is what? 41 degree by the arc. So AB is the arc. So whose length has to be found. You see that? What is the length of the arc intercepted by a center angle measure 41 degree in a circle of radius 10 feet. So therefore OA, OB is 10 feet and you are going to find the length of this arc. So you know the relation between arc length and the center angle and the radius. So the angle is denoted as theta. Theta is equal to 41 degree. It is in the degree measure. And the radius is equal to 10 feet. So we know that theta is equal to S by R. So here S has to be found. So S is equal to R into theta. So R is what? 10 feet and theta is 41 degree. So it is in the degree measure. You know how to convert into radian. So if you want to convert into radian, what should be in the numerator? Pi. So pi by 180. So the 41 has to be multiplied with pi by 180. So this is 0 and here 0 getting cancelled. So it is 41 pi divided by 18. So the pi value is what? It is 22 by 7. So here 22 and 18 getting cancelled with 2. So it is 11. Here it is 9. 41 into 11 is 451 and 9 7s are 63. So when it is divided, okay, so see that it is 7.158. So it is approximately 7.16 feet. So the length of the arc is 7.16 feet. And the next one, you see that this model problem is an important 3-mark problem. You see that if it is in two circle, arcs of the same length subtend angles 60 degree and 75 degree at the center, find the ratio of their radii. If it in two circles, so we are considering two circles, in the two circles which are same, arcs of the same length. So the length of the arcs are same. They subtend different angles. One is 60 degree in first circle and 75 degree in another circle. Find the ratio of their radii. So we have to find what is the ratio between the radii. So what is given that arc lengths are equal. So usually we will denote arc length as S. So here two circles are there. So therefore one is S1, another is S2. Here what is given that they are equal. So what is the formula for the arc length? S is equal to R theta. So for the first circle R1 theta 1 and for the second circle it is R2 theta 2. So here theta is involved. It is a 60 degree, that is in degree measure. So we have converted into radian measure. So it 60 has to be multiplied by pi by 180. You see that theta 1 is equal to 60 degree implies, okay, 60 into pi by 180. So that is equal to, you see that 0 0 getting cancelled, 1 6 is 6, here it is 18, so 3. So pi by 3. So what is theta 1 now in radian measure? It is pi by 3. In the same way, theta 2 is equal to 75 degree implies the 75 into pi by 180 means 75 degree is converted into radian. So see that when you simplify with 5. So it is 15 pi divided by 36. 15 and 36 can be cancelled with 3. So 5 3s are 15 and 12 3s are 36. So it is 5 pi by 12. So theta 1 and theta 2, it is given in degree. So we have converted into radian measure and substitute here. So R1 into, what is that? Pi by 3 is equal to R2 into theta 2. It is 5 pi by 12. So in the R2, when you take it to the left side, it is divided by division, and this pi by 3, when you bring it to here, it has to come in the reciprocal. So it is 3 by pi. So this pi and this pi getting cancelled. So 3 and 12, when you cancel here, you will have 4. So R1 by R2 is equal to 5 by 4. So the ratio is nothing but 5:4. Okay, come to the problem number 8. The perimeter of a certain sector of a circle, the perimeter of a certain sector of a circle is equal to the length of the arc of a semicircle having the same radius. Express the angle of the sector in degrees, minutes and seconds. Okay, see what is given that here I have drawn the sector. OAB is nothing but the sector. Okay, the perimeter of a certain sector of a circle. So I have drawn the circle. Here I have taken a sector. In that sector, you have to find the perimeter. So what will be the perimeter of OAB? What is OA? It is the radius. So the radius is taken as R. OB also radius, that is R. So here AB is the arc, so whose length is S, and this subtended theta at the center. Okay, so perimeter of the sector, so it is nothing but this distance plus this length. Okay, up here it is R plus S. Okay, that is equal to the length of the arc of a semicircle. So I have drawn the semicircle, and that semicircle also having the same radius. So the radius of the semicircle is R. Okay, this is the arc of the semicircle. Okay, so can you say what is the length of this? It's nothing but if you take the full circle, the perimeter or the circumference of the circle is how much it is? 2 pi r. But here it is a semicircle. So 2 pi r by 2. So adala half da 2 pi r la half. Appa 2 pi r by 2 is pi r. So the perimeter of the sector of a circle is equal to the length of the arc of the semicircle. Okay. So full circle circumference is 2 pi r. Here what is asked? The length of the arc of the semicircle, that is equal to pi r. So 2r plus s is equal to pi r. So s is equal to pi r minus 2r. From that r is common. If you take it out, it is pi minus 2. Here you are getting r into pi minus 2. So here what is asked? The angle of the sector. But here it is arc length is given. So we know the formula. Arc length has to be written as r into theta. So both having the same radius. So r getting cancelled. You are getting theta is equal to pi minus 2. It is in terms of radians. Pi is involved, so it is in terms of radians. But what is asked? In terms of degree, not only degree, minutes and seconds we have to write it. So the radian has to be converted into degree. Degree means the 180 should be in the numerator. So it is 180 divided by pi degree. Okay. So what will be the next step? So here what you have to do? The pi has to be substituted as 22 by 7. So see now here pi. This pi has to be written as 22 by 7 minus 2 into 180 by 22 by 7. That only I have written here. Okay. So if you take LCM, it is 22 minus 14. So here this LCM is here also 7, here also 7, both 7 getting cancelled. So the denominator you are having 22. So 22 minus 14 is 8. 8 into 180. So 8 into 180 if you multiply it is 1440 by 22 degree. So you see that the calculation, see now it is 1440 has to be divided by 22. So 6 22s are 132. So the remainder is 12 and drop the 0. So here now you are having 120. So 5 22s are 110. So the remaining is 60. The remaining is 10. Okay, this 10 degree has to be converted into minutes, that is 10 by 22, like that it has to come. So the 10 has to be converted into minutes, so you have to multiply into 60. Upon 10 into 60, because 1 degree is equal to 60 minutes, so 10 by 22 has to be converted into minutes, so it has to be multiplied by 60. 10 into 60 is what? It is 600. This 600 has to be divided by 22. Okay, 2 22s are 44, the remaining is 16, drop this 0, it is 160, so 7 22s are 154, the remaining is 6. So here from the minutes, so we move to the remainder 6, that is 6 by 22. Okay, the 6 has to be converted into second. So again 60 minutes is equal to 1 second. Okay, about 6 into 60, so that is equal to 360. So 1 minute is equal to 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. So therefore the 6 has to be multiplied into 60. So 6 into 60 is 360. This 360 has to be divided by 22. When it is divided, 122 is 22. The remaining is 14 and drop this 0, 140. 6 22s are 132. So the remainder is 80. You just leave that. So you see that first this is 65 degree. Here it is 27 minutes and 16 seconds. Okay, so here the remainder is multiplied with 60. Then it is divided by 22. So the quotient is in terms of minutes. And the remainder is multiplied with 60. When it is divided by 22, this quotient is in terms of seconds. Okay, so therefore we can write 65 degree 27 minutes. Minutes ko you have to write one code and seconds ka double code has to be written. So 65 degree 27 minutes and 16 seconds. Okay, so we will come to the problem number 9. You see that an airplane propeller rotates 1000 times per minute. Find the number of degrees that a point on the edge of the propeller will rotate in 1 second. So see that it is given per minute how much rotation is given. Now what do you have to find? What is the number of degrees will be made in 1 second? Okay, first we will see that the number of rotation per minute is given what? 1000. So the 1000 rotations per minute. This per minute can be written as 60 seconds. Both are same. So 1 minute is equal to 60 seconds. So therefore the number of rotations in 60 seconds is 1000. So our problem is what is asked? 1 second. So the number of rotations in 1 second is what you have to do? 1000 divided by 60, that is 100 by 6. I didn't calculate, just I keep it. 100 by 6 rotation in 1 minute. Okay, you see that for one rotation, what is the degree is made at the center? It is 360 degree. You know very well. One full complete rotation over, in terms of degree, the number of the angle made at the center is 360 degree. So you see that number of degrees formed in one rotation is 360 degree. Here how much rotation is taken in 1 second? 100 by 6. So the number of degrees formed in 100 by 6 rotation is equal to, what you have to do? 100 by 6 into 360 degree. So when you divide by 6, it is 60 degree. So therefore 100 into 60, that is 6000 degree. So therefore the number of degree formed in 1 second is 6000 degree. Okay, so come to the problem number, what is it? Next problem, that is the 10th problem. So what is it? A train is moving on a circular track of 1500 meter radius at the rate of 66 km per hour. what angle will it turn in 20 seconds? You see how the train is moving along the circular track. The track, railway track is in circular. So now your train is moving on the circular track of 1500 meter radius. So the radius is 1500. Okay. At the rate of 66 km per hour, the train is moving. So 66 km per hour. What is that? 66 km per hour. That is the speed of the train. Or we can interpret 1 hour. Within 1 hour, the train has to cover 66 km in the circular path. Okay, you see that for example. So this is the position, starting position. Okay, so you see that here the radius is 1500. It is moving on the circular track, isn't it? It is moving on the circular track. So 1 hour, after 1 hour, B is the position of the train means. So after 1 hour, so how much distance it covers? 66 kilometer. That's the meaning here. That's the speed of the train. So R is equal to 1500 meter. The speed of the train is 66 kilometer per hour. So 1 hour, what is the distance traveled by the train is 66 kilometer. How the distance? This distance is not straight. The train is moving on the circular path. So that AB, that is the arc length, is the distance traveled by the train in 1 hour. So that is 66 kilometer is nothing but the arc length in 1 hour. This kilometer, but radius is in terms of meter, so it has to be converted. So the arc length is equal to 66 into 1000 meter. What we know? Theta is equal to S by R. So the arc length is given and the radius also is given. So if you calculate, you see it is 660, 2 zeros getting cancelled. So 660 divided by 15. When it is cancelled, it is 44. It is in terms of radian. What is that? The angle turn in 1 hour by the train is 44 radians. So what is asked? What angle will it turn in 20 seconds? So therefore the angle turn in 20 seconds. Here it is 1 hour. So the hour, when you convert, it is 3600 seconds. So 1 hour is nothing but 3600 seconds. So angle turn in 3600 seconds is equal to 44. From that we are going to find angle turn in 20 seconds. So what you have to do? 44 into 20 divided by 3600. Okay, 0 getting cancelled, and 2 divided by 360 is 180. So what you are having here? 44 by 180. So now we are going to convert into degree. Okay, so degree means what you have to do? 180 by pi has to be multiplied with that. This 180 and this 180 getting cancelled. Here the pi value is what? It is 22 by 7. So the 7 will go to the numerator. So 44 into 7 divided by 22. 22 and 44 is cancelled. So here you are having 2. 2 into 7, that is equal to 14 degree. Okay, so we'll go to, before moving to the last problem, we should know about the area of the sector. So we are going to move to the formula of area of the sector in degree as well as the radian. Okay, you consider this diagram. Here the area of the semicircle is marked here. Okay, so you know that if it is asked area of the semicircle means, you can write it is pi r squared by 2. You know, area of the whole circle is pi r squared. For the semicircle, it is pi r squared by 2. Here this semicircle is nothing but the sector. Yes or no? This arc length subtends how much angle? It is 180 degree with the center. So it can be written as half into pi r squared, you know very well. This half, instead of half, we can write it as 180 degree divided by 360 degree. So the whole full rotation is 360 degree. Only half rotation has taken place. So it is 180 degree by 360. When you cancel, you will get 1 by 2. So come to here, find the area of the sector, this sector. So you see that the circle, the angle made here, it is 90 degree. So it is, how many parts we can divide? It is 4. We can divide the circle into 4 equal parts. So this part is nothing but the total area divided by 4. That is 1/4 of total area. Okay. So the 1 by 4, instead of 1 by 4, this sector makes how much angle at the center? 90 degree. So 90 divided by 360 degree. When you cancel, you will get 1 by 4. Okay. So see now, in the same way, we are going to find the area of this sector. Okay. We don't know what angle it makes. So we have taken as theta. So here you see the angle. Here the angle is 180 degree. So how to find the area of the sector? 180 degree divided by 360 degree into pi r squared. Here the angle is 90, means how it will be written? 90 degree by 360 degree into pi r squared. In the same way, here your angle is what? Theta. So therefore the area of the sector formula is theta divided by 360 degree into pi r squared. So this is the formula to find the area of the sector. So the center angle is theta, means, so the total area, so pi r squared is the total area. From that into theta by 360 degree. Okay, so you have to write in terms of radians. What you have to do? Here 360 degree is there. So this 360 degree in radian, how it will be written? It is 2 pi. Okay, 360 degree is equal to 2 pi radian. So here 360 degree in the place you have written as 2 pi. So this pi and pi getting cancelled. So r square theta by 2. Okay, see now. So this is the formula to find the area of the sector. Okay, if I come to the problem number 11. A circular metallic plate of radius 8 centimeter and thickness 6 millimeter is melted and molded into a pie. Pie means a sector of the circle with thickness of radius 16 centimeter and thickness 4 millimeter. Find the angle of the sector. See now, a circular plate whose radius is 8 centimeter and thickness is 6 millimeter. Here, one not only radius, the thickness is also there. Okay, it is fully melted and molded into a sector. The sector also you are having the radius as well as the thickness. Find the angle of the sector. So here the circular plate with the thickness is given and it is converted into a pie. So the whole area, both the volumes are same. Here you are having, along with the area, you will have one more dimension, that is thickness. So we have to say about the volume. Okay. So otherwise you can write area of the circle into thickness is equal to area of the sector into whose thickness. Okay, instead of saying the volume, so I have said area of the circle into thickness, that is length into breadth into height. In the same way, 2 dimension, it is involved in area. So area of the circle into thickness, that is totally converted into this pi. This pi is in the form of a sector. So area of the sector into thickness. Okay. So what is the area of the circle formula? It is pi r squared. What is the thickness of the circle? It is 6 millimeter. You look at your radius. Radius is in terms of centimeter, but thickness is in terms of a millimeter. So 6 millimeter I have written. Here also, coming to the area of the sector. Just now only we have learnt what is the area of the sector in the degree. That is theta divided by 360 degree into pi r squared. In terms of radian is what? R square theta divided by 2. So therefore r square theta by 2 into 4 millimeter. The 6 millimeter has to be converted into centimeter is 6 by 10. Here 4 by 10. Coming to pi r square. What is r? R is the radius of the circle. What is the radius of the circle is given? 8 centimeter. So r squared means I have written 8 into 8. Okay, come to here. R squared. What is this r? It's the area of the sector. So whose radius is 16 centimeter. So 16 into 16 into theta divided by 2. The 4 millimeter is converted into centimeter. Okay. So this 10 and this 10 getting cancel, and this 2 and 4 when you cancel, the numerator you will have 2. You see the calculation. So what's the first one? The denominator 10 getting cancel, and we are moving to the next calculation. You see that here what I did, this 2 and the 4 getting cancelled, so in the numerator you will have 2. And look at the left side. Here you are having 8. This 8 and cancel with 116 means here you will have 2. And the same way second 8 with this 16 is 2. Here 2 and 4 getting cancelled, you are having 2. So here what is remaining? Pi into 6, that is equal to 2 into 2 into theta into 2. Okay, so see that 6 pi is equal to 2 into 2 into theta into 2. So that is 8 theta. Okay, so 6 pi is equal to 8 theta. What is asked? The question, find the angle of the sector. So we will have to find theta. So theta is equal to what? It is 6 pi by 8. So when you cancel with 2, it is 3 pi by 4. So the angle of the sector is equal to 3 pi by 4 radian. If you want to give in degree, it has to be multiplied with 180 by pi getting cancelled. So 3 by 4 is 180. So you have to go for it. Okay. Thank you, students.